In the Edexcel IGCSE Maths exam, vector proofs represent a significant portion of the marks available in the higher tier papers. Our goal is to use algebraic vectors to prove exactly when lines are parallel and when points align on a single path. To do this, you will need two specific skills already in your toolkit: finding vector paths and factorizing algebraic expressions. Applying this structure turns geometric diagrams into a sequence of algebraic steps. This method allows you to verify your results through calculation rather than visual estimation. Step 1 is establishing the mathematical rule for parallel lines. Here are two vector arrows, A and B. If one is equal to a constant number, a scalar, multiplied by another, they are parallel. Algebraically, 9a plus 6b factors into 3 times the expression 3a plus 2b. That outside 3 is the scalar defining the relationship. Isolating that common bracket is the definitive way to prove parallelism in an exam. Once we can prove lines are parallel, we can move to collinearity, proving that 3 points lie on a perfectly straight line. To prove points A, B, and C are collinear, first show line segment AB is parallel to segment BC. Then state these parallel segments share a common point. Here, both connect at point B. Parallelism shows the segments point in the same direction, but the common point proves they are physically connected on the same path. Before we execute a full proof, we need to address how to handle ratios correctly. A common mistake is seeing a 3-to-1 ratio and assuming the first segment is 1/3 of the total line. The correct method is calculating the total number of parts first. In a 3-to-1 ratio, 3 plus 1 gives us 4 total parts. This means the first segment represents 3/4 of the total line, while the second represents 1/4. Converting ratios into these specific fractions ensures your vector paths stay accurate throughout the entire calculation. Let's apply these steps to an exam question. We have a trapezium OABC, where AB is parallel to OC. Point P divides the diagonal AC in a 3-to-1 ratio. First, find expressions for foundational paths OB and AC using base vectors. By our ratio rule, segment AP is 3/4 of vector AC. To find path OP, we travel from O to A, adding our fraction of AC. Simplifying gives the final expression for OP. Next, we compare our result for OP against the full vector OB to check if they are parallel. When we factorize the expression for OP, we reveal it is a scalar multiple of OB. Both expressions now contain the exact same bracketed terms. This shared bracket confirms that vectors OP and OB are parallel. Finally, we note that both parallel vectors originate from the exact same location, point O. Because the vectors are parallel and share a starting point, O, P, and B are mathematically proven to be collinear. You have just completed a high-tier vector proof using factoring, fraction conversions, and the shared point rule. To reinforce these steps, your next action is to attempt an active practice problem. This quiz focuses on the same proof structures we've just covered. Passive observation helps you understand the logic, but solving these problems independently is the only way to prepare for the actual exam. By following this logical framework, these geometric proof questions become a series of predictable, solvable steps.